So I give you that one. What would you know about A if I gave you that parabola? It's positive because it's opening up, okay? So keep that in mind. What other things should we know? And you can look at the parabola to figure that out. What else? We should know the y-intercept. How do you find the y-intercept? What's happening there? Merry Christmas. I want that to go away. There we go. All right. Y-intercept is what? The y-axis. And how do you find that? How would you go about finding it? Not yet. What is it? Yeah, you plug in 0 for x and see what you get, right? And that would be the y-intercept. Okay, so what else? You said axis of symmetry. That's a good one. What do we know about the axis of symmetry? It's reflected. Okay, so then it would come right here. That'd be about where it is, right? It comes out of the vertex. So it's the x value of the vertex. How do we find the axis of symmetry? There's a little formula. It is negative b over 2a. Okay? So you do want to know that. All right. So axis of symmetry, negative b over 2a. How does that help you find the vertex? So this gives you the x value of the vertex. To get the y value, you plug it back into the function and see what you get. Is that okay with everyone? Okay. And the vertex, if you're not sure, right there, that's the vertex. Okay. A couple other very important things to remember. They went by several names. The roots, yeah. Where are the roots on this thing? Yeah, or what's another name for roots? X-intercepts. Okay, so that's where they are, right? Oops. Everything again. Right. So then x-intercept right there. X-intercept right there. Okay, so there are roots, x-intercepts. What else are there? Zeros. And then finally, solutions, okay? So, if there's solutions, then how do you solve a quadratic equation? Or, yeah, there's many ways, but how are you supposed to be able to solve it right now? By graphing it, right? You graph it, I showed you the different ways to manipulate the calculator. Problem with graphing is it's only an estimate. So we'll do other ways to solve these soon. And back to what Tabitha was saying, like kind of the flip side, right? She said, when you find the y-intercept, that's when x is 0, right? The x-intercepts are when y is 0, and that's why this is always going to be set equal to 0 here. Is that okay? All right. Get some good stuff now. So, you ready for some good stuff? You ready for the good stuff? You don't sound as excited as you ought to be. How's that red look in the back? Bad? You go back to white. All right. If the solution to a quadratic equation is where it crosses the x-axis, what do you know about that parabola? There's no real solution. Okay? So that's important. Real numbers are all the numbers like decimals, fractions, things like that. However, it does have something called imaginary solutions. Yeah, good stuff, right? So that's the thing that we're going to talk about today. So the title of it is complex numbers. We got to talk about complex numbers before we can even talk about how to deal with them in the solution. Okay? And before we can even talk about complex numbers, we got to talk about imaginary numbers. Okay? So there's going to be a lot of definitions that you may or may not feel good about. And then we're going to start manipulating some stuff. So, There is a lot going on here in the next 20 minutes. You need to make sure that you ask as we go, because a lot of what I'm going to talk about is technically review. Now, it's only review if you remember it, okay? Or it's only review if you actually have seen it before. Neither of those things may be true, okay? But it is things that you are supposed to know. So, I'm going to cram a whole bunch of stuff in, really, in a very short amount of time. And you may not know what I'm talking about, and so then you have to ask. Does that make sense? Okay. So, first question is, what is the answer to that? Negative 2. What? Something 2. Positive 2. Negative 2. What's the square root telling you to do? Find the number that's multiplied by itself to give you negative 4. So then, there is no such number, because a negative 2 times a negative 2 is positive 2, right? A positive 2 times positive 2 is, positive 4. I said that wrong. Negative 2 times negative 2 is positive 4. Positive 2 times positive 2 is also positive 4, right? There's no other way to get about it, okay? So, what if I said, well, we could rewrite this. Can you accept that we could rewrite it like this? Can you accept that? Right? It's kind of a rule of radicals that you may or may not remember. Okay? So, our first definition that we're going to talk about is, what is an imaginary number? Okay? So an imaginary number, we're going to call it I. Let's see that one. I. We're going to say that is now the square root of negative 1. Okay, this is a definition. So then really what we would say here is that this is I square root of 4. Now what's the square root of 4? 2. So then we would get to 2I. So is that okay? As in, like, did you follow?
So the definition is the I.
So so this is the definition of an imaginary number right there. Okay? So that's new. Now, one of the things that you have to keep straight when you're dealing with imaginary numbers is that you have to change it to imaginary numbers, which means make the negative an I. Okay, if you do not do that first, you're going to lose your signs as you go. Okay, so that's the very first thing you got to do. Is that okay? All right, so if we look in here, and so that's the imaginary unit, right? So, right, the imaginary unit is this. It's also the definition of an imaginary number. Okay? And so then if we look down here a little bit, they say 6I, negative 2I, I radical 3. And they're calling them pure imaginary numbers. And now this part I'm going to say that you don't have to know today. But this is what we're going. Complex numbers, which is the title of this section, are made up of an imaginary part and a real part. Real being all the numbers that you're used to dealing with. Okay? So what this pure imaginary number, what they're saying is, if you only have the imaginary part of a complex number, we're going to call it a pure imaginary number. Okay? That's going to make a lot more sense when we deal with complex numbers here tomorrow. Okay. So far, what you need to know is I is the square root of negative 1. Ready? Is that okay with everybody? So there's a little bit more to that definition that we have to deal with, because you can multiply imaginary numbers together. Okay? So I'm going to show you the 4 options that you would have. Okay? So the first option, it's going to be down in here. The first option is just what we started with. We could say that I is the square root of negative 1. So again, you're never going to write square root of negative 1. You're just going to say I. Now what happens if you take I and multiply it by I? So that would be like this. I times I, close.
It's -1.
So yeah, so then it would be, because it'd be the square root of -1 times the square root of -1. Now, if you said, what did you guys say, 1? Okay, so then this is where you have to deal with it being imaginary first, okay? So basically what we're saying here is that this is going to be the same as, does it make sense that I can write it like that? Okay, so then like a square and a square root are like inverse or opposite operations, so they kind of cancel each other out. So then we're going to say that it's -1. And what is it? I squared is -1. Okay? So a little bit more of the definition. Because you're not supposed to be answering anything with an I with any other exponent than 1. So if you get to I squared, don't leave it as I squared. Change it to -1. Is that okay? All right, so now we're going to multiply it again by I, because that could happen. So then, if you're okay with this step, if I multiply by one more I, is it okay to write it as I to the third? Okay, so then we're saying I to the third. Well, so it's an equation, that's supposed to be a 3. So it's like an equation, so then I'd multiply the other side also by I. So -1 times I. Is that okay? And again, this is definition. When I'm asking, is it okay, are you following what I'm saying? Okay? Because I don't need you to like break it down and analyze everything. Like, if I go through this and it's like, yeah, okay, that makes sense. What you need to remember is that if you're never going to tell me I cubed, you're going to tell me -I. Okay? So again, what does it say? Never tell me the square root of -1, call it I. Never tell me I squared, call it -1. Never call it I cubed, call it -I. Okay? We got one more step to deal with. Okay, so that would be I to the 4th. If we do it again, right? I to the 4th. So then, again, this is a question like, does this make sense? Can you follow this? Would it be okay to say I to the 4th is the same as I squared times I squared? Is that okay? Because this is like the reverse of your exponent rules. And then what did we just say I squared was? -1. So then really what we're saying is I to the 4th is -1 times -1, which is what? +1. Okay, so then again, I don't need you to create these. What you need to do is say, okay, if it's I to the 4th, it's 1. Is that all right? Now that takes care of every single exponent it could be. Because now if you see, if we get to I to the 4th, it's 1. If we multiply it by I one more time, 1 times I is just I. So then we're back here. And so what I'm telling you is that I to the 5th is just I. Because we can write I to the 5th as I times I to the 4th. Okay, and then we just said I to the 4th is 1. Okay? So then we could say I to the 5th is I, then that means I to the 6th is -1. And then I to the 7th, where'd it go, is -I. And then I to the 8th is back to 1. Okay? I to the 9th is I to the 10th is -1. I to the 11th is I to the 12th is 1. And this pattern just repeats and repeats and repeats and repeats. Okay? Now there's an IXL that just does that. They give you I to the 78th, and then you figure out which one it is. Okay? This book doesn't look like it's going in that direction, but it's an easy process because it's always going by 4s, which is a division problem for you if you're looking for it. All right, how's it so far? Feeling pretty good? All right, we're going to start simplifying radicals. So, I'm I assume that you don't remember how. So, let's do another little bit of review before we move on. What's the answer to that? 3. Why is that 3 again? 3 times 3 is 9, okay? So I'm going to write this in a couple different ways to kind of explain what's going on, okay? First way is kind of the most simple way to think about it. Would you agree that the square root of 9 is the same as the square root of 3 squared? Square rooting and squaring, inverses, kind of cancel each other out. 3, okay? Another way to think about it, and this comes with fractional exponents, which I assume we will get to. Do you remember fractional exponents at all? Okay, so you don't have to know that for this. Okay, but it's a grouping thing. Okay, so we don't see a number out here, which implies it's a 2. Okay, and I'll do another example when it's not a 2, just to make sure you understand what I'm saying. Okay, so what this is telling us is we want to group factors in group sizes of 2. So if I took 9 out to the side and did a factor tree with it, I would have one group of 2 3s. Is that okay? And so then one group of 2 3s would be the 3. Is that okay? All right, let's do one a little bit harder than that. Don't be afraid to ask, because this is a lot of stuff. So let's just do something like the square root. We'll just make it easy. Let's just do the square root of 8. Is there a square root of 8? No. Okay, so there's a lot of different ways to think about this. In my experience, most people, like most by like a lot, like 80% or more, like to do this with the factor tree. Okay, so I am going to skip all the fractional exponent explanations and go straight to a factor tree. Okay, so what that means is you're going to take whatever's inside and make it into a factor tree. So we got 8. So what's that break down to? Well, we're multiplying. Okay? And so now we're looking for group sizes of 2. And I know that because there's no number in front of my square root. So then I got one group of 2 2s. Is that okay? If you're doing it by the factor tree, every time you circle something, it gets to come outside of the radical. Okay? So this group, and I'm going to show you one more idea of this here in a second. This group becomes 2. Is that okay? This one, right, I'll change the color for you. Right, this one didn't have a group. So now it has to stay inside like that. And these are easy to check, right? You can get it on your calculator. Square root of 8 gives you some weird decimal. 2 times the square root of 2 gives you the same decimal. Okay? The only other connection that's going on here is that you can think about this, we'll look at the same problem, as we can say the square root of 8 is the square root of 4 times the square root of 2. Does that make sense? Well, so because 4 times 2 is 8. Is that okay? Yeah. Okay. And so now we know what the square root of 4 is. It's 2.
Okay.
Is that right?
Yeah, why didn't you do even with the 4? Like you have the
Where are you looking?
8, like you have the...
Right here. You're talking about this.
Yes.
Yeah, because we go all the way down to its prime factors.
Right.
So we actually did do something with the 4. It became a 2 and a 2.
Okay, and then you use another 2.
And then this other 2 didn't have a partner, right? It has no friends, stays inside all day because it's like friendless. Yeah, it's super sad.
Or
Yeah.
like,
Yeah. Is that okay?
Yeah.
All right. So now she's bringing up, Riley's bringing up a point that you got to pay attention when you're doing a factor tree, because right, you can get a bunch of numbers running around and then you miss one and like where to go, then all of a sudden you have the wrong answer. Okay, so you do have to really watch where all your numbers end up going. Okay. All right, so is that okay? All right. So one more thing just to make sure that you understand this whole grouping idea. What if I gave you instead the cube root of 16? So if a square root is what is a number times itself that gives you that inside number, a cube root would be what times itself 3 times gives you that number. So for instance, the cube root of 8 is 2 times 2 times 2. So the cube root of 8 is 2. Okay? So again, this number out here, and I know this is a lot, okay? There's a lot going on right now. Right? This is telling you what size groups you're looking for. We need group sizes of 3. All right? But you treat it the same way. We take 16 out to the side, 2 and 8, 2 and 4, 2 and 2. Okay? Looking for group sizes of 3. We got one group right there. Right? 3 2s. So they all have friends. Get to go outside and play. The other 2, super sad, right? It's like a mean girl situation. They like, you stay away, we don't like you because we're mean girls. I don't know if that's true or not. But. So then the cube root of 16 is 2 cube root of 2, yeah.
If you're grouping the 2 from the line above, that one, why couldn't you group the other 2 in?
Because you're saying this is up here?
Yeah.
Okay, so it doesn't matter where they are. If you go all the way down to the prime factors, and this is kind of like what I was saying, right? Like, yeah, you're going to lose some, but the point is that 2 times 2 times 2 times 2 is 16. So no matter where it is, it's fine. So you could have included these, but then this one down here would be left out.
So basically we just did 8 times 2 is 6, and but basically that's how you put it, because
Yeah.
2 cubed would be.
And so basically, yeah, if you're thinking of the other like kind of way that I said up top, yeah, you could say, well, this is really right. You could say, okay, well, so the cube root of 16 is really the cube root of 8, right? Times the cube root of 2. And so, okay, so well, the cube root of 8 is 2, and so then we get right to here. Now, the problem with doing that, and the reason that I don't usually teach it that way is, and again, you guys aren't dealing with the cube roots. I'm just trying to enforce like what's going on. But the problem is like how many cube roots do you know? Okay, so like how many perfect cubes do you know? Like when we're talking about squaring, yeah, 2 squared is 4, 3 squared is 9, right? Even though 9 squared is 81, 10 squared is 100. Maybe you remember 11 squared is 121, 12 squared is 144, and then I doubt many of you know 13 squared. Okay, so then how far can you go though, right? Okay, so but so then with the cubes, how many do you know? Probably not very many, because 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed, I don't know, we're getting pretty big.
So you just want to do my math? That's why.
Huh?
You just want to do it? Because my math, because you're pretty good in your cube.
Yeah, well, so, right, but I've been doing this a long time. Okay?
So basically, I think what I'm asking is why couldn't that, instead of that being 2 cubed, and then the square root of 2, why can't that just be 8, and then the square root of 2? Wouldn't that be the same thing?
But say it again, like I didn't follow.
Like if you were to put 8 in front of the square root of 2.
Cube root of 2. Is that what you're talking about down here?
Try it with the.
Yeah, right, it's right. See, like.
No. I don't know. I'm confusing myself, I guess.
So, okay, so what I don't want you to get confused on is like, you're not dealing with the cube roots. What I'm trying to say is like, this is a grouping thing, so we're grouping it 2. Okay? And again, you can check these pretty easily. Like you could type in the cube root of 16, you're going to get some decimal. And then if you type in 2 times the cube root of 2, it'll be the exact same thing. So we've simplified it now. Okay? And so another part of maybe not what you're asking, but what we should understand is these are exact numbers, which are important enough. As opposed to, yeah, it's like 2 point whatever. Okay, that's good in sometimes, but if we, exact numbers are gonna be more important, okay? And so that's kind of also what's up. Okay, so that's a good question. These are good questions. This is what you guys need to do, okay? Because this is a lot of stuff. Okay? So we okay so far? All right, that's the background. Let's get to example 1 then. All right. So the book writes it out a little bit differently, okay? Again, in 15 years, I've experienced that most of you will like to do the factor tree, okay? And those of you that don't care if it's a factor tree or not are fine with it being this way also, okay? So I'm going to do the factor tree because I'm trying to condense a whole bunch of stuff into like a short period of time. All right, so here's what you guys are going to do with this. We're trying to simplify the square root of negative 294. The very first thing that you have to deal with is that we're taking the square root of a negative number, which makes it imaginary. So the first thing I want you to do is just say, all right, this is I square root of 294. So again, they're doing it slightly different. But you need to deal with that negative number first. Okay? Now, we're just going to break down 294. Okay? So it's just going to be a factor tree. I don't know what it really is. I'm going to cheat a little bit because they told me what it is. It's really 49 times 6. Okay? Now, how do you get this normally? I don't know. It's an even number divided by 2 and then keep going. Right? But I do know that it's 7 times 7 and 2 times 3. Is that okay? Looking for group sizes of 2. Found it. Okay? And so then what I'm saying is that group comes out. So then we'd have 7i square root of 6. Where does the square root of 6 come from?
The 6 that never stopped split up.
Yeah, it became a 2 and a 3, but it didn't have any groups, so it went back in as a 6. Now, I'm not asking you guys to ignore things that you knew before. You could say, like, hey, man, I knew that the square root of 49 is 7. So why did I keep breaking it down? No, I'm pretending you know nothing, basically, okay? So you can always stop and be like, I know what the square root of 49 is, it's 7, boom, I'm done. Okay, so then this is your final answer here. Is that okay? You all right? Yep. All right, so let's do this one. We're going to do a couple of these, make you guys should, hopefully we'll start feeling a little bit better about it. All right. All right, square root of negative 75, what do you got to do first? I. So this is going to equal, what's happening? Fat hand, I got fat hand. This equals I square root of 75. Now what? Factor 75 down. Right? There's a bunch of ways to do it. What do you got?
Would A be an answer or no, since you can?
It's not simplified. Okay, so everything needs to be simplified. And then this reminds me of another thing, and I'm kind of trying to say these things, but not explicitly. But A, everything should be simplified. And B, like one of the problems people have in Algebra 2 is that all of a sudden you're getting all these rules and you're allowed to use them anytime you want. And then someone's going to do it different than you. And it's all okay. All right, so pretty much the time of do it this way or it's not going to work, that's not necessarily going to be what's going to happen, okay? Some things will still be like that, but other things are going to be like, I don't know, you got a bunch of rules, what are you going to do? I don't know, okay? But 75 becomes what?
25 and a half.
Don't divide by a half because we need prime numbers, no fractions.
25
So 25 and 3. Okay, and again, I'm going to go down to 5 and 5. And I understand that we're running out of time, but we're almost done with what we need to do. So it'll be okay. All right. Group size of 2. All right, so then the final answer is C, because it's 5i radical 3. Did you have it backwards? Yeah. So be careful. The thing you circle is on the outside. Okay? Because it's a square root of 25, which is 5. You wanna do one from your homework? All right, pick number 1. And the homework is 1 to 12, because we won't get, right, like, it's just 1 to 12. So give me number 1. What is number 1?
So the homework for tomorrow is 1 to 12?
1 to 12, yeah.
Square root of negative 48.
All right. All right, so what do we do? I squared root of 48. First thing you should always do on these. Twelve and 4. Right, start with anything. I'm going to keep going. I know that you know the square root of 4, but wait, we got 2, 2, a 6 and a 2, and a 3 and a 2.
So then what you just put, it'd be like 2, so it'd be like 2i, and then you would just put the 12 on one side.
Well, you got to be careful because the 12 gave us 2 more 2s.
So you put the 6.
No, the 6 became the 3 and the 2 at the bottom. So the only thing inside is the 3. Okay? So then it would be 2 groups of 2. 2 groups of 2. So a 2, and then another 2. Okay? I, and the lonely kid that has to stay inside.
That's the answer.
So yeah, I mean, I would write it 4i radical 3. Should we do another one? Yep. So number 6, negative 90, not square root of negative 99.
9 and 11.
Okay, so then, right, you deal with the I first. Take 99, like you said, it's 9 and 11.
3 and 3.
There's our group size 2.
Three I the square root of 11.
Is that all right?
Can we do number 7 with
Yeah, so, okay, so that's the next example. So, yeah. All right, so is this okay? Because this is like the whole thing. Like, if you can do this, then, like, the rest of this is going to be pretty easy. Okay, so, like, yeah, let's. Okay? And again, they do it a lot better than, like, they've done it before. So, again, the very first thing you see is they dealt with their imaginary numbers. Okay? Now, you may forget how to multiply radicals together. But what you do is multiply the outside numbers together, and then you multiply the inside numbers together. And then that's how we got to I squared square root of 150. Is that okay? Okay, so then you multiply the outside numbers, which would be I times I. There's where your I squared comes from. And then you multiply the inside numbers, 10 times 15. That's where the 150 comes from. Okay? So now, again, they do it a little differently, but like I'm going to take 150, right? Break it down, 10 and 15, 2 and 5, 5 and 3. There's our group size of 2. Okay, now I squared is one of these ones that you got to remember, okay? I squared becomes negative 1. Okay, and that's where this negative 1 comes from. Is that okay? So then that's negative 1 times the 5, right there. Square root of 6, because that 2 and the 3. And then you multiply. Yeah.
So you do that. Why did it separate?
Which part?
I don't know.
So again, right? So the 6 comes from, like, this one, there's only 1, 2. There was only 1, 3, so then you multiply them together to get in here.
Right, so I'm looking at like we have I squared and then there's like times
Mhm.
right? And then where did we get 25 times 6?
So this is like, they're doing it a little bit different than I'm doing it.
Right.
So their 25 came from like right here. This is their 25. So this is like if you multiply these two together, you'd have the square root of 25.
So because they're from different sides, you'd have to multiply the other two together.
So since these didn't have a pair, yeah.
So if they were anything like that.
Yeah, so it could be like 2, 3, and a 7, and then it'd be 42.
Yeah, it would still work right if the 5 was on the outside, so it was like, I guess it would.
Like you're saying if it was this way.
Yeah.
Yeah, totally.
It wouldn't make a difference.
Yeah, it wouldn't make any difference, yeah. Okay, I just write them like this because it's easier to
No,
circle.
I understand.
Yeah, okay. All right, how's that? All right, so that's, so 1 to 12, but you gotta do it, because if you don't do it and I don't know what you're having issues with, like I can't answer any questions tomorrow, we're gonna go to the next thing. Okay, so these dates over here are probably gonna be bumped up a day, but that was the hard part. Like, so like everything else, you'll be like, okay, no big deal. Okay, so that's the hard part of this section. Yeah,
I had a question.
Yeah.
On, number 3.
what is it?
So when you break it down, it's 72, it goes into 9 and 8.
So is the square root of negative 72?
Yeah, no, yeah.
Okay, and so then
So it's
72 is 9 and 8, okay, yeah.
And then 3, so what goes into 9 is 3 and 3, and then what goes into 8 is 4 and 2.
Yeah.
And with the 4, you broke it down again.
Yeah, you can't write the 2 and 2, yeah.
And then, so would the answer be 3i square root of 2?
You're close, you're missing part of it. Because here's the 3. Yeah, you're missing that right there. So it'd be 6i, so then it would be 6i
So,
square root of 2.
okay,
Is that okay?
yeah.
I didn't even like interrupt.
No, good, I'm glad. So it's a little bit weird and you're gonna get used to it, but it's not like this, like I said, this is the hard part of this section right there.
Yeah, we don't sure. 23, you get,
Yeah, right there.
56, you're broken down to 22, right?
Right, so then you use this
Oh.
honestly, it doesn't matter really what 23 times 46 is. You're just factoring around and factoring all the way down. Yeah,
Oh
it's like a little bit more time we can talk about it.
Oh my god, like yesterday, whenever I said that. No, I can you think?
Did you stop recording it?
No, probably
not.
You'll be the last thing. Don't worry, nobody ever watches it, so like,
Why did you go to school?
it's fine.
You're still recording.
Oh, shoot.
Sorry.